Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, what if AI didn't just learn, but evolved itself like a team getting smarter together over time? Today's paper, Sage Multi-Agent Self-Evolution for LLM Reasoning by Yulin Peng and Xingxin Su. Here's the problem. Modern LLMs improve reasoning using reinforcement learning, but they depend heavily on massive human-labeled datasets. That's expensive, slow, and not scalable. Self-play methods try to fix this, but they often miss structured planning and lack strong quality control. So the big question is, can AI systems train themselves reliably and keep improving? Sage introduces a really elegant solution. Instead of one model, you split it into 4 roles. Challenger generates problems. Planner creates step-by-step strategies. Solver executes the solution. Critic evaluates everything. These are not separate models. They're roles played by the same LLM. They form a loop. Challenge, plan, solve, critique. And here's the key insight. The challenger is rewarded for making harder problems. The solver is rewarded for solving them correctly. So they push each other forward like rivals in a game. Now let's go deeper into how training actually works. It starts with a small seed dataset, just 500 examples. From there, step 1. Challenger generates new questions plus verifiers. Step 2. Critic filters low-quality ones. Step 3. Planner creates structured plans. Step 4. Solver produces answers. Then everything is updated using reinforcement learning, specifically task relative reinforce plus, which normalizes rewards across roles for stability. This is crucial because multi-agent RL can easily become unstable, and this keeps learning consistent. Let's break down the reward system. The challenger gets rewarded based on question quality. Difficulty, meaning how often the solver fails. Format correctness. The solver gets rewarded for plan quality. Verified correctness, proper formatting. And correctness is checked using external verifiers like unit tests for code or exact answers for math. No human labels needed. The critic plays a surprisingly important role. It scores both questions and plans and ensures everything follows a structured format, like enforcing tags such as question or answer. Without this, the system would drift, generating garbage data over time. So the critic acts like a quality gatekeeper. Now, what about results? Sage shows consistent improvements across model sizes. For example, on Quen-2.5-7b, it improves performance by plus 8.9% on code benchmarks, plus 10.7% on Olympiad level math. Even more impressive, it generalizes better to out-of-distribution tasks. There's also an important insight from ablation studies. Remove any one agent and performance drops significantly. No challenger, weaker curriculum. No solver, biggest reasoning drop. No critic, unstable quality. This shows the system works because of role specialization plus collaboration. Let's look at a real example. The challenger generates a math problem. The planner breaks it into steps. The solver follows those steps, and the critic scores everything. This creates a clean reasoning pipeline instead of messy, unstructured outputs. Now, pitfalls. First, Sage only works in verifiable domains like math or coding. Second, training too long causes over-specialization. Performance actually drops after a peak. Practical tip: monitor validation accuracy and apply early stopping. Another limitation, it still needs a small seed dataset. So it's not fully zero data yet, but it drastically reduces human supervision. So what's the big takeaway? Sage turns a single LLM into a self-improving ecosystem where data generation, reasoning, and evaluation all happen internally. And here's the exciting question. What happens when these agents start using tools, browsing the web, or interacting with real environments? That's where this idea could truly explode. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.